Thank you very much. Yeah, so I'd say, yeah, coding is definitely one of the main use cases we're seeing obviously proliferate at this particular point. I don't know if anyone has not touched one of the systems at this point to generate code, and now everybody across the board is generating code on some level. And so obviously, as that happens, code reviews become even more important, right? We now live, right, in this whole new ecosystem. AI is driving just about everything. We have groups of people who are saying, I haven't written a line of code in the last 6 months or since the beginning of the year. And so how do we adapt? How do we change the way that we work in order to accommodate this new way of working? And so we use, just looking back, right? Handwritten code, pre-AI. Have a bunch of CI/CD pipelines, tests, linters, a whole bunch of things just to try and make sure, again, that what we're writing is good, is solid. When it goes into production, it's not going to break everything. And then we move into this AI-assisted coding, right? So we have Copilot, ChatGPT, Cursor, and others, Codex. And going into the future, an AI-driven where we're just using agents, right? In the background, I say what I want or what I'm trying to accomplish. Maybe I provided a lot of business context of what's going on. And then I walk away and I let these set of agents go off and I let them code everything. How do I know what comes out of it? How do I validate what comes out of it? How am I sure that it didn't build a lot more or a lot less than what I wanted? How am I sure that I was specific enough in my asks so that it actually knew what to build rather than making assumptions that was against what I was trying to go for? And so we have this new way, right? This new ecosystem. Code generation, super fast. Code review, super slow, right? We're generating a lot of code. If I have to read that 15,000 line PR that you just opened with your background agents, I'm not gonna get through it. And I'm not gonna be able to do a good job, right? And so this old way of doing things, we have a new bottleneck, right? We have a new bottleneck in the review and the validation portion of the workflow. Just to get a little bit more concrete, 1 billion lines of code generated per day. This is a little bit old even from Cursor. 30% increase in the number of pull requests of people, again, shipping features at a higher velocity. And then we have a big increase in the number of bugs within those PRs. So we're actually compounding the problem. Not only do we have slower bottleneck in reviews, but we actually have more things to find. And so that is a massive scalability challenge when it comes to how do we make sure, again, that our production systems aren't breaking. Previously, we had 15 to 25% of a developer time going into code review. And this is some of your more expensive resources even. You have your senior and architect level engineers getting in there trying to make sure that the quality bar is high. But it's 100 times more expensive to fix it if it gets to production. So you want to spend that effort. You want to spend that resource because you don't want those things to happen in production. And in some cases, enterprises, you're talking about up to $5 million per hour of downtime. So this is a really big problem that needs to be solved, right? That's the cost of bugs. And so should we just let Claude Code or Cursor review their own PRs, right? So they've already generated 41% more bugs in their code. So should we really trust them to find those bugs after they just generated them? They tend to be optimized for speed, right? If I'm sitting there at my CLI and I'm using Claude Code or I'm using Cursor, they're meant to be interactive. They're meant to engage with a human being, and so they don't necessarily take the time required to actually find those hard-to-find bugs. They're not focused on all of the features that you would need as part of a code review because it's not their main product, and not everybody uses the same tool. So the quality and the differences in the review is going to shift depending on the developer, and so as an organization, if we're trying to set some sort of quality standard, we sort of lose the ability to do that, right? We want to have some sort of consistency in the bar that we're trying to set. And so we have this new, what we consider the new AI dev tool stack. You have your code generation systems, and they might be agentic, they might be fully in the background. You might be having them sort of asynchronous. And then we have your central repository, GitHub, GitLab, Bitbucket, Azure DevOps, these kinds of things. And you need some sort of AI code review system in order to help manage the amount of code that's coming in and the proliferation of bugs that are being inserted into your code base by these new AI-generated PRs. So CodeRabbit obviously sits there, and that's what I'm going to talk about today. So we're used by a lot of different companies across the board, including at NVIDIA. We're a Series B company. We've raised over 88 million in total. We have over now 250,000 monthly active users, 75 million plus defects found, and we've reviewed over 3 million pull requests. There are 3 ways that you can use CodeRabbit inside your system. If you're a developer and you're on your laptop and you want to use it in the IDE or in a CLI tool, maybe even feed it directly into Claude Code. There's a plugin that you can just hook CodeRabbit directly up. And ultimately, we also live in the central layer, which is, I think, one of the most important places for something like AI code review to do, is to live in that central layer so that you can make sure that everything that goes into production has been evaluated by some tool that's looking for these bugs. And so that works across all those different platforms. Now, the way that we do it, okay, so how do you deal with code review? Getting into some more interesting points of the conversation. Every task, right, that an AI has to do, and you'll hear this over and over again over the past, I'm sure, 6 months or so, is that context is king. What would I need to do to be able to review your PR? I need information. If I've been at the company a while, I have a lot of accumulated information, but even still, if I look at code that I wrote 6 months ago, I might not even recognize what I did. So I need to go and need to understand it. I need to go and I need to look around, right? I might need to read the issue. How did this come about? What are we building and why? I need to look at the surrounding code. If you changed a function signature in some way and it's used elsewhere, I need to understand, did you break something? If I'm a consumer of that, did you change the core functionality that would break some sort of contract between the consumer and now the producer? And so there's a lot of context enrichment. The vast majority of the work done is in the context enrichment side of things. And we can use a lot of domain expertise in order to make sure that that context enrichment is happening in a way that would effectively make me able to review that PR, right? So we have to clone the repository. We have to do this thing, and we do code graph analysis, how your code and your PR is connected up to the other aspects of the code base. Issues, so I was talking about earlier, why? Why did you build this? What was the purpose of it? What were you trying to accomplish? You can connect MCP systems. So for example, your architecture documentation, your coding guidelines, things that your standards that you might have, I should evaluate it against that, make sure that everything's adhered to. Maybe you have a specific way that you do encryption, making sure that that's adhered to as well, or security posture. And so then you have other things like you're using coding agents, right? You're using Claude, you're using Cursor, you have these MD files, you spent a lot of time putting a lot of information for how these systems should work into those. So we need to take those. We need to make sure that the code being generated actually adheres to those guidelines that you set. And then we do other things. There's personalization inside code review. One company might never want variables to be public in a class. Another company doesn't care. So which one, do I show the error or do I not? Ultimately, you want to make sure our product is geared towards finding as many bugs that exist as possible and then letting you decide what are the ones that you want to see on a regular basis. And so what happens is you chat with CodeRabbit, you tell it, oh, we don't do this in my company, this is something I don't care about, and it learns over time so that the reviews become more and more personalized to however you work, right? And so there's a lot of other stuff that goes in there. Web queries is a great one. So libraries change all the time. Sometimes they're breaking changes. Models obviously are out of date when it comes to that information. And so we need to go out and we need to look at the documentation to make sure that you're adhering to whatever version that you're using. And then we go through this whole loop. Yeah, it's got a review, and then we have a verification system to make sure that what came out is grounded in truth and fact, and there's no false positives coming out. And then finally, we get to output the comment. I would say 80 to 90% of token usage is in the actual context enrichment itself. 80% of our actual usage. The rest, the review agent itself, it's a very heavy reasoning task, but all that heavy lifting of finding what it needs to actually do the job has already been done by that point. Just want to talk a little bit about the evolution of prompt engineering and what goes into some of this. So obviously, start off prompt engineering, you ask it to do something, it fails, or it doesn't give you exactly what you want. And so you give it some examples, right? So this is the idea. I'm going to do few-shot prompting. Little tiny changes. Ultimately, it's a very static prompt at the end of the day. It solves some tasks fairly well, but it doesn't really adapt to dynamic context. So that's why context engineering comes from, right? This is designing the input environment so that the model has what it needs to reason accurately. So it's combining, right, prompt engineering with dynamic context gathering, something that's going to sort of provide all the information necessary. And so that's how we fit into all this. And I wanted to call out, sort of, because this is NVIDIA and Nematron event, is that Nematron actually can sit in our self-hosted environments in this middle layer that's used a lot to drive the actual information that the reasoning system ends up consuming. And so this is where you have your clients, your CLI, your extension, your GitHub repository coming in. All that context gathering takes place. And then we're using Nematron to be able to synthesize that information and then handing off to Claude or GPT, in which some cases Opus, some cases Sonnet, some cases GPT 5.4 or 5.3 codecs, in order to do the actual heavy lifting of the reasoning tasks. To get a little bit concrete on some of the things that we do, to give you an idea of the breadth and how you have to think about your problem space, right? And use your domain expertise to try and figure out what is the context that's necessary. And luckily, we're CodeRabbit. We're in an engineering space. We have engineers driving the product. Engineers are familiar with the code review process. And as we view where it does well and doesn't do well, we kind of get ideas behind, what information did we maybe miss that we could put in there that would help the LLM figure out the bug, right? And so we have a whole knowledge-based system. So some of it's personalization. You can set up your own path, what we call path instructions. You say TypeScript files, I want them to be reviewed like this because I have something I do unique. We index past PRs so that if you're fixing something and it's related to a past PR and something went wrong over there or something is unique, we can make sure that that same problem doesn't occur here or that the information is correctly pulled out. Your coding guidelines, like I refer to, the learnings that you're going through, we have an index of the code base in synthesized form so that, again, we can find if you're doing authentication work, where else is authentication happening? What is the way that you do it within your organization? And we also now have something that's multi-repo, which is that we actually pull information from, so say you're doing front-end work, we can pull information from your back-end repository and make sure that your front-end is not violating some usage of the back-end systems. Or if you update the back-end, that now you're not breaking something on the front-end. So I was talking about this earlier. This is an example of it. We want to get rid of star imports. This is a comment made by someone on a PR in open source. And then CodeRabbit says, okay, understood. This is a past preference that they had that you would collapse multiple imports and you just use star instead. So we gave that comment. They came back saying, oh, we don't do that anymore. And so now we added a new learning and actually removed the old ones. So this new learning says, it now prefers to avoid wildcard and actually instead use explicit imports. So that in the future, we don't make that same comment. And if someone does use a star import in the future, we pull that in and it says, don't do that, right? The idea is that to figure out how your company works. This is a very, very heavily used feature. All right. We added MCP. MCP systems is used all over the place, but the main problem with them, if you've ever used them in any kind of agentic context, is that the context window gets bombarded by information that may or may not be relevant, because something being somewhat semantically similar does not mean that it is useful in the context that you're in. And so when we bring in information from your MCP gateway, we're searching for data on things like your architecture, your security posture, or anything that might be like a PRD document we might be searching for related to this PR. We have to go through that then, and we have to say, okay, is there information in here that's actually relevant to the task that I'm doing right now? And we have to extract that information so that we're not overloading the main context window with extraneous stuff. Because as everybody knows at this point in time, the more information you put into LLMs seems like a good idea at first, but then it starts forgetting things, right? Things in the middle start to get lost. If I have too many instruction sets, too many things that it has to keep track of, by the time it gets to the end, some of that information is just lost. So this is actually an optimization problem on top of just finding the information. We now need to optimize for the task at hand. And this is why context engineering is difficult. I can't just throw everything in there. We have linters. Ultimately, they come through and they do simple stuff. Oh, there's a bandit B303 error, right? And sometimes there's a lot of false positives in here, but if we feed them to the LLM and use a reasoning system on top of it, we can get rid of a lot of the false positives, but we can also explain in the cases where it's true, why it's true, so that, again, people can make fixes very easily. We can actually recommend patches to fix those issues. But this is one of the biggest ones, and this is where it doesn't just help to put in the diff. So the barrier to entry to code review is very small, right? But thinking about all the different ways in which something can break requires you to start thinking about outside the PR and thinking how things are connected. And figuring out that information of how things are connected, potentially multiple orders deep, depending on the type of issue. Like a concurrency issue might come from many levels in order to hit your PR. And so this is where outside diff impact slicing comes, right? So if I look at this example, I changed, say, for example, the process refund and added an exception. The handler doesn't know that, and it wasn't updated, and so now the handler has a bug. Because when that exception gets raised, it's just going to break the system. And so this is where, if you fed that to an LLM, it'd be like, you should probably handle this error in here. And then how you style it up. This is becoming less of a bottleneck as it used to be, but depending on how you dress up your context window will alter how it behaves within the LLM. If I use JSON, it will behave one way. Typically, JSON's been used a lot for tool calling, so that can have certain impacts if you do that. Ultimately, it also uses a lot more tokens to use JSON, but you can dress it up in a lot of different ways. We tend to use more markdown style output using tags in order to be able to reduce tokens, but also the LLM seems to not overemphasize on tools when we don't use JSON. So this is an example of how we format the envelope of information for the LLM. All this comes back. I found this really interesting. It came out a little bit a while ago now, but many people have probably seen it. Out of Stanford, there was a paper called ACE, Agentic Context Engineering. And what I found really interesting about this paper is that it is an automated version of our learning system. So they showed that when you use Agentic Context Engineering, you can have this generator, reflector, and curator loop that will allow you to systematically determine ways of augmenting your context or your prompts and your strategies inside those prompts for potentially even gathering context in a way that you don't need to fine-tune an LLM to see a pretty significant uptake in terms of the actual accuracy or the metrics that you care about in terms of the performance of your task. And so this is very similar when I was looking at this to our learning system. The difference is that the reflector and the curator is the human. We provide the comments, the human comes in and says something in response to those comments. We look at that, we translate that into something we can apply generally as a strategy going forward, and we curate that list over time. So it's actually, I found this really interesting because we saw that massive improvement as a result of having that to be personalized, but also just to do a better job overall. And it was interesting to read a paper that kind of reinforced that in academia. So after each review, track which signals lead to helpful versus noisy. And this is why you would do it if you were automating it, right? You would take a reflecting agent and you would say get some patterns out of there, say most valid issues are tied to ASG grep matches, or lint only comments were rarely accepted. It depends on what things you care about, right? What are the evaluation criteria and the way that I'm going to actually reflect on whether it's a good or a bad generation. And then depending on that, I would then go through and take out some sort of learning and insert that into my original prompt, or my original prompt that leads to my context gathering. So yeah, very interesting. This is pretty much exactly how learnings work, only with people. Another thing I just wanted to point out is that the way that we handle code review, because obviously code, if you're doing anything related to code, security is extremely important, right? This is the IP of every company, its most valuable asset outside of its people. And so you have, encrypted in transit, ephemeral LLM queries, so everything gets destroyed. When we bring up a sandbox to clone the repository, as soon as that review is done, that entire thing is destroyed. We never store or keep any code within our actual system. We have zero data retention and complete data isolation between any given task, so no one else is co-located with any code base. Because there's potential remote code execution here. That's why our sandbox and jail environment is so strict, because ultimately, as there are holes in linters or whatever else might come up, we want to make sure that the blast radius is contained within that single repository itself. So you can only hurt yourself. That's the general thesis. I wanted to show a quick demo here. All right. Yeah, well, not really live, no. Some examples. Just generally speaking, I was going to show a few things. So one, just to give you an idea of what the code review could look like, and you have the ability to tune this yourself. You can customize the summarization. You can get rid of it. You can sort of make CodeRabbit your own, right? So whatever you like. But the idea is that first thing it does is it analyzes the PR and figures out what happened, so that we can give some level of summary so anyone coming into this has some basis of where they are and orienting themselves to figure out what's going on. So that's the first sort of thing. And then we have a walkthrough, which guides through each and every file, what changed, and the description of that change. So again, anyone who comes in and wants to figure out what's going on, I don't know if anyone's coming into a large PR and being like, what is going on here? This is where you can orient yourself and figure out what's happening. Right, so that comes into here, and then we have a system sequence diagram, which again can help you understand the data flow within the PR itself, and if you like, there's a poem as part of this. A few more examples of actual issues. So here, for example, we have a critical issue that's caught. I don't know if I can make this a little bigger. There we go. Code will not compile, obviously a big issue. I'm not sure how this PR got created, right? Invalid, await error, hand syntax. So, it's sitting there searching for all kinds of stuff, including things that are somewhat on the obvious side of things. But interestingly enough, you can also find complicated things like potential race conditions, right? So again, things that are inherently a little bit even difficult for sometimes humans to find. Concurrency issues being sort of chief among the most difficult to understand. And the other thing I wanted to point out for people who use it is sometimes there are problems that we find that are just around the PR. So like they're in the code of the same file, they might overlap with the PR, but ultimately they're just outside. GitHub doesn't let us post comments there, at least not via the API. And so we post those in this outside diff, again, showing another issue that is straddling your PR. And ultimately, we provide a lot of patches, right? Trying to make it very easy. And on top of that, I'll show you a little bit later, but we're actually providing a lot of prompts for your AI systems to be able to fix these issues automatically. And so we have another example of some critical security issues. So someone had CodeRabbit scanned for specific types of security issues, and we come up and we do, again, a full clone of the sandbox. Even when you're chatting, you can actually chat with CodeRabbit, ask questions, ask it to do extra things, and it will actually do the entire thing. Well, it will clone a repository, do all that stuff, agentic loops, context gathering, to try and answer that question. And this is a question about security vulnerabilities, and so it went and did a thorough scan and found some issues. Here's another one. This case, again, this was a SQL injection vulnerability that it found. So someone had inadvertently added something where the user would have control over a variable that would go into a SQL query. And so it pointed out that you might want to do some data cleansing before that. Right? So all these things, finding these security issues save a lot in the long run of potential issues and potential data leakage. Here's the memory leak that it discovered. Again, this is for C and C++, and we've all been there. And this is the example I showed earlier, actually, the learning, where someone had done a bunch of imports, and we suggested going to star because originally they had wanted a collapse, but that had been reverted. And so this is an example of where the new learning was added and the old learning was removed as a result of the change in the way the repository wanted things to be reviewed. Here's an example of MCP being used. So again, pulling in context information, because context is king here. If you want to be able to find problems, you need to know what you don't know. And so some of that involves discovery, right? And so this is an example where MCP systems were used to discover information about a PR. We have this feature called pre-merge checks. In some cases, it's not a bug in a specific part of the file. It could be something else entirely. And this happens after when you're ready to merge, it'll do some other checks. So this one is, for example, a requirement that this user had or this repository has around feature gating. It noticed that this new thing was not feature gated, so the pre-merge check failed, and it gives a reason why. And ultimately, then it prevents the PR from going through if you have it configured that way. You can also just have it notify you and kind of let things fall where they may, or you can have it actually reject the PR in the same way that a human would. And then finally, this is something relatively new. We rolled out a planning system recently. And so this uses the same general framework of our context gathering. And again, all the information that we have and the way that we view context engineering as being a longer running task to make sure something is done well. And this is an example of somebody had an issue that they had brought up, and they described the bug, the steps to reproduce the bug, and then they asked us to plan for them and find a solution to the problem. And so we went through, we came up with a plan, and along with prompts that you can go and copy into your coding systems, so Claude Code or Cursor or Codex, to use to implement this. And then I wanted to just briefly show, it's very easy, but ultimately I want to show what it's like, what the app looks like, and then I'll move forward. This is more the live demo portion. Dangerous. All right. So this is what a plan kind of looks like within our interface. Is another example of a planning system. It comes with design choices. So these are the assumptions that were made. Oh, this is really hard to see. It's tiny. These are the design choices that were made by the system. And again, the plan comes out with tasks, and you can go through and validate them. You can also ask for changes within the system and iterate on it. But going back to CodeRabbit. Back. So you come in, you can hook up all your repositories. We have these cool dashboards where you can see the health of your repo, as well as your organization, I should say. All the active repositories, pull requests, everything that's going on. All this stuff lets you know, first of all, how many bugs am I finding and how many bugs are my people accepting and all this other stuff, but to let you know the health of your repository. But yeah, that's sort of where you can configure things. So if I go into configurations and whatnot, I can kind of see how, first of all, I have an example PR that I can see what it's going to look like when I'm done configuring it. But all this stuff is sort of meant to be highly adaptable. And right now, my organization has hard settings on my PR, so I'm not allowed to change anything. But that's sort of the way that you get into the app. It's really easy, just clicking on logging in with your GitHub. All right, let's go back. Here, yeah. There's one other thing I want to play. How do I go back? Is it going to play? That's the question. Oh.
100% of NVIDIA's engineers use AI for code generation. The same number of engineers check in 3 times the amount of code than before. At this scale, keeping code quality high is impossible with just human reviewers. CodeRabbit's review agent gives thorough feedback as volume grows. The agent is a system of models, using frontier models like Claude and GPT for state-of-the-art capabilities, and open, efficient NVIDIA Nemotron models, customized with proprietary data for fastest response time. CodeRabbit pulls from NVIDIA's code, knowledge base, trackers, documentation, and more to fully understand the changes. Using its large context length and reasoning capabilities, Nemotron iteratively summarizes, extracts insights, and packages the context for frontier models, which flag issues and suggest fixes. As our engineers iterate, the loop continues until the code is merged. Now, receiving feedback on code takes minutes instead of days.
All right. Let's go back. All right. Let's go. All right, so these are some of the statistics we've got from some of our customers, right? So Groupon, for example. Not only are they finding more issues and obviously having fewer things going into production, but actually as you use the system, as you adopt it, and as you gain trust over what it can do, it can actually really accelerate your ability to have PRs merge into production, right? So some companies, for example, used to have two mandatory reviews on the system will end up going down to one as they learn the system, as they personalize it, and they make sure that it does what they want it to do. And so this obviously not only speeds things up, it also helps alleviate some of those resources so that people can stop trying to review the massive amount of PRs that are being created. So 50% faster, time to first code review, number of PRs per month, 36% more, time to merge 50% faster, and number of forced merges 60% less. So that's a good example, but ultimately the idea is here, improve velocity, ship more code. I think that's what all of the engineers want. We all want to build things in one level or another, regardless of whether you are someone who's in marketing, coding, and wanting to build something for your team or yourself to make your work easier and make it more efficient. Everybody wants to build something. That's why these tools are so useful and why people are gravitating so much to them, right? Now you have an idea, you can go out there and build it. We want to make sure that the quality bar remains high while that throughput is increasing. So a few things to remember. LLMs do reason better with better context, but more context does not mean better context. Domain expertise is better context. So thinking about, in this domain, what information would I need? So the only way to really experiment with that is to go out and try it on some things, right? Try and build some things, try and understand what context is needed, and try and figure out how you can optimize that context. I used to have an example here where I wrote a 50-line review product in Python, and it would review some Python code, and it came out with nothing. And the idea was it was just looking at the diff. And so then I took the surrounding code and put all of it in, and it was a small enough repo you could do that. And it would find the issue. It was, I think it was at that time, 200,000 tokens it would use. Seems a little bit excessive. And then when you optimize it, the diff itself was 17,000 tokens. And by only adding 1,000 more tokens, which is just a very carefully curated set of where it actually connected up with the rest of the code base, you can find the same issue. So the idea is the optimization problem is how you end up doing it in a cost-effective way. So what you can do if you want to try out CodeRabbit, it's a free trial, 14-day. You can go in and just sign up with GitHub, right? Very easy to set it up. And you can hook it up to Jira Linear to understand why you're building what you're building. And you can hook it up very easily to your MCP systems to figure out PRD documents and various other things like that. So there you go. Here's your next steps. I want to leave some time if anybody has any questions.
Got a question right here up front.
Hi, I'm Smita, and I work for NVIDIA as a program manager. My question is, you said there's 100% data isolation and 0 data retention. Also said you bind the context injection to optimize the token usage. So how do you know, or how does CodeRabbit know what to bind? How does that work? Can you double click?
Yeah, so finding what to discover within the code base, right, in order to understand that. So every single time we have to rediscover the context, right? So when your PR comes in, it's connected to certain information. So we know certain things are going to be needed. So we look at the code graph. So we actually build at that moment a connection point between your code and the ways that it sort of connects out from in a graph, right? So if I'm using a function from a different class, that would be an edge, right? If I'm importing certain things, that would be another edge. And so I build a graph. And I can build that a certain number of layers deep, and then I know that's a starting point. And based on that, I now have additional context. I don't have to put all of the code in there, but I have some more information. And now I can use that to do agentic discovery, where I can actually start to run shell scripts and bash scripts, ripgrep, things like this, to discover additional places I might need to look at. And this is what happens sort of in the background before the review event actually takes place. Every single review, that happens again. And every PR is slightly different, right? So we don't need the same information each time. So every time that could be large, depending if you have a large PR, or it could actually be very small if you're changing very little, or your changes are self-contained within the file, for example.
Very cool. I do want to remind people we do have a raffle. I'm gonna come to the back. I appreciate everyone who sits up front, but nobody in the back ever gets to ask questions.
Hey, Max Gerhardsen. Great presentation, by the way, really interesting. I had a question. Earlier in your talk, you discussed how you can actually have a conversation with the CodeRabbit and sort of direct it into what your company best practices are, right?
Yes.
And so you can do that at the local level and also at the CI level. And is there communication from one level to the other? And how would you manage sort of conflicting claims, especially at the CI level?
So usually we try and detect conflicting claims when they come in. So if someone's chatting with CodeRabbit in the GitHub ecosystem, so you saw before, we deleted an old learning based on the new learning because we detected that they overlapped, right? So we're going to show conflicts that happen as they happen, and we will update you in terms of how learnings either have been added, removed, or updated. So if you do something that's slightly related, we might actually build on top of an existing learning, similar to how the ACE paper works. But yeah, conflicts are something that you have to manage, right? So something you have to actively look for.